Hello, welcome to Leading Digital. My name is Antti Pikkusaari. Today I will introduce a data capability maturity model. The overall model is extensive and rich with contents, but for now we'll focus on three topics. First, the basic idea behind data capability maturity model, why I felt that such a tool is needed. Second, what are the four maturity levels? What makes up each level and how the levels differ from each other? And what would data capability evolution look like? Finally, we'll have a quick look to different use cases when maturity model is used as a practical tool. This is what data capability maturity model looks like. To be precise, this is what its main navigation view looks like. Indeed, each text element in this view is also a hyperlink to description, for example, what do we mean by data mesh? Background information with more in-depth perspective and useful links to further details. Related tools, for example, what are the tools data engineer needs to do his job? Ecosystem players, for example, who are the leading companies for data storage solutions? Finally, sometimes the topic calls for short presentation to capture its essential characteristics. For example, there's more to data ops than meets the eye. However, before proceeding to details, let's have a quick look on what was the point of all this. In other words, what was the idea in the first place? Justification for data capability maturity model builds on two things. First, it's about a systemic perspective to data capabilities. That is, by nature, data capabilities have lots of dependencies. For example, business processes have high reliance on tools and technologies. Secondly, only when data capability buildup is done with a systematic approach can we ensure competitiveness in long term. That is, a point solution serving individual market need may perform well as a short-term painkiller, but will face integration and scalability challenges later on. Those problems can be avoided with a systematic take on data capability buildup. So what exactly are the acting forces behind all this? Let's have a look. The basic promise of data is straightforward. With data and analytics, including artificial intelligence, we are able to create higher customer value and better customer experience. Productivity is further improved through enhancements to operational efficiency. So far, this is fairly simple. However, complexities start to emerge when we recognize the core characteristic of data. It is everywhere and it connects to everything. It is data that leverages new technologies into productivity boosters. Any new digital technology would be virtually useless without data. Data is also heavily involved in products and services needed to deliver value to customers. And it integrates deep into business processes when we aim at running them more efficiently. When the number of different data sources, data types, and use cases are combined with massive increase of data volumes, we can seek comparison from natural history. Cambrian explosion introduced millions of new species to Earth some 500 million years ago. Right now we are experiencing Cambrian explosion of data creatures. All of the above translate to one thing: massive management challenge. To cope with highly dynamic business environment consisting of markets, customers, and competitive landscape, and with internal complexity stemming from technology and operating model, and, last but definitely not least, people and the new skills needed. Data capability maturity model is designed to tackle this management challenge, to navigate the data capability minefield, to provide concrete tool for strategic change management. Let's move on. Now, let's take a closer look to data capability maturity model. This presentation is based on version 1.0, with new versions already in the pipeline. The main navigation view has simple table structure with rows consisting of elements of data capabilities, grouped in four main categories. The first group consists of data sources and types, volume and scale of analytics data, and analytics use cases. In a way, this is the group that sets requirements for all other groups. That is, what are the capabilities needed to serve the multitude of data sources and types with ever-increasing volumes? Operating model consists of three main themes. First, business processes, methods, and ways of working. Second, organizational structure and human capital. Third, governance for general decision-making as well as data itself. Data management is a useful term for data specifics within the overall operating model. This group is a collection of technology-related themes: architectural design, data platforms, and cloud computing. Data stack refers to the total set of tools used in connection to data management processes and methods. The final group is about management agenda. The emphasis is on senior business management perspective. Agenda topics vary from maturity level to another, from getting the analytics ball rolling to scaling up data capabilities. Strategy themes cover strategic planning as well as implementation. For successful data capability build-up, strategic change management needs to be in the heart of CXO agenda. Maturity levels approximate the stage organization has reached in its data capability journey. The levels are not absolute. Any given company can be on one specific level, but quite often its current capabilities map to at least two different maturity levels. But before diving into maturity level details, there's an elephant in the room that cannot be ignored. Let's talk about data strategy. Data strategy provides the essential framework for data capability buildup. Data strategy is sometimes understood as some kind of action plan listing tasks to perform to do data, to become data-driven. Well, that's clearly not enough. Instead, a good data strategy integrates analytics tightly with the rest of the business strategy. To achieve that, it must explain what data brings to business and how analytics is to be used for leverage. Most companies are not in data business. Rather, they are in product, service, or combination of the two business. Hence, the role for data and analytics is basically straightforward. That is, how to create higher customer value and better customer experience with products and services, and overall through all customer journey touchpoints. If we are able to do that, we differentiate from competition, and then all good things result from that. For example, we increase our pricing power for healthier margins and improved profitability. This is what business expects from data. The second key domain is operational efficiency. That is, how data and analytics are to be used across business processes and functions. This too leads to better profitability, this time through gains in cost efficiency. Finally, a good data strategy brings clarity to data capability buildup. This relates to choices on operating model, technology and data platforms and architecture. Ideally, a data strategy provides an outline for implementation path, that is, some kind of a strategic roadmap. The third data strategy domain takes us very close to strategic change management and data capability maturity model. In other words, data capability buildup can be kicked off without data strategy. However, the further we go, the bigger risks without foundation set by data strategy. The need for solid foundation is evident. The three data strategy domains need to be aligned. Data capability buildup must be rooted in strategic objectives in terms of product, services, and processes. And vice versa, no point of planning for analytics-boosted offering or operations if data capabilities are not there to back them up. In short, a good data strategy is integrated and aligned. Those three domains form the data strategy hardcore. However, there may be other important strategy elements. For example, Quite often, data enables new business models. For example, IoT data from installed base may take service business to a whole new level. By default, artificial intelligence and machine learning are integral part of all the three core domains. So basically, they are nothing special. However, sometimes it may be beneficial to have dedicated strategy section for AI. For example, if Quantum Leap to an AI organization is targeted as part of the overall strategy, or if it's necessary to highlight AI's importance for productivity and competitiveness. As mentioned, most companies are not in data business but in product, service, or solution business. Data may have significant book value, but whether that translates to data monetization as a strategic item is another matter. However, sometimes additional revenue streams from data products can be significant. In that case, data strategy must clarify the opportunity and how to capitalize that. With these considerations on data strategy, let's now return to data capability maturity model. Now, let's investigate each maturity level, starting with level 1. Data maturity level 1 is the starting point. At this stage, data is mostly transactional rather than analytical. Most of the company data connects directly to enterprise applications and business processes they serve. In other words, data has important role in operational efficiency gains, but only indirectly as part of enterprise applications. Whatever analytics there happens to be, it's in embryonic stage. In that, the available transactional data is sometimes used for new insight. However, analytics-related activities are ad hoc and reactive. Volumes are low and lead times long. Let's move on. Next, let's have a look into level 2. With analytics emergence, data ceases to be only about transactions. A whole new data plane dedicated to analytics gets established alongside with transactional plane. Data no longer comes from enterprise applications only. Rather, now sources of data are many, ranging from web-based customer interactions to third-party data. At this stage, data type is still limited to structured data available in table columns and rows. Maturity level 2 mode of operation is best described as boutique analytics. In that, volumes are still relatively small. Processes are immature and not designed for scale. Analytics work is much about tailoring and tinkering done by multi-skilled data artisans. No formal data governance exists. In addition to data artisan recruitment, the first real investments into data capabilities are now made, starting with BI tool and data warehouse. Data engineering emerges as key activity running ETL process to extract, transform, and load data. At this point, data science is based on statistical analysis rather than machine learning. Next, let's dive into level 3, analytics proliferation. This is where a lot starts to happen. Maturity level 3 is about explosion of value creation, driven by data and analytics. The game is about to change. Individual data sources are now counted in tens or more. Data types are about big data with structured and unstructured data. Data is no longer loaded in batches only, but also as continuous stream of events. Use cases are diverse and many. Data volumes used for analytics purposes increase by factor of 100 or more. The name of the game is big data, in the true meaning of the word. Ability to predict and prescribe emerges as new basis for use cases and value, driven by machine learning models and algorithms. Analytics is now much more than business intelligence with visualized reports. Now data really starts to deliver its promise. Products and services create more customer value and delight. Processes run more efficiently with data-driven insight. Looks good, doesn't it? But there's a catch. No pain, no gain. To tap into data-driven value demands data capability build-up not seen before. It all boils down to scale, combined with speed and quality. And that is a non-trivial undertaking. Here's a compact list of things to take care of. This is where the concept of strategic change management emerges from. Hub and spoke is a useful way to describe organizational structure for data capabilities. The trick is to find optimum balance between centralized hub and distributed spokes. The optimum changes over time. Balance that worked fine yesterday may be unoptimal tomorrow. Cloud computing as technology platform offers superior capabilities in terms of scalability, flexibility, agility, and innovation. To reach for analytics in scale, speed, and quality builds on cloud computing-based solutions. Because of this, cloud migration becomes an integral part of data capability build-up. Cloud-based data platforms like data warehouse and data lake are foundational elements in data capability build-up. Because of fundamental scalability needs, architectural design becomes central activity. Architecture should be seen as a key element in the strategic change management toolbox. Requirements for data engineering and data science reach a whole new level. Data engineering emerges as a fundamental enabler in data management landscape, with vast complexity combined with need for scale, speed, and quality. Top-notch data engineering becomes a critical success factor. No longer can data governance be overlooked. Instead, well-designed and established governance practice becomes cornerstone for data discovery, access, and quality. Overall, maturity level 3 is about high-performance operating model. Processes need to run smoothly to cope with complexities and volumes, and to achieve speed and quality. Indeed, high-performance operating model is the cornerstone to capitalize on data-driven value. Compared to earlier levels, maturity level 4 is somewhat futuristic with higher levels of uncertainty. In other words, while it makes perfect sense to build a strategic data capability roadmap all the way to level 3, with definite steps to be taken, level 4 steps are less definite. However, as a future outlook, level 4 is worth investigating. Let's dive in. Maturity level 4 outlines evolutionary states where data analytics has become commodity. It has become business as usual. A good analogy would be mobile internet. Not so long time ago, mobile data was seen something special, different from traditional internet based on wireline connectivity. This was reflected by operating model design with mobile-specific elements. Well, no longer. Nobody talks about mobile internet anymore. It seems reasonable to assume that analytics will evolve into similar status, that is, data capabilities fully distributed and embedded into all organizational corners. Let's see how that would look like. Maturity level 4 is about 3 closely related and interconnected themes, all reflecting the embedded nature of analytics. Let's go through them one by one. Analytics becomes pervasive and embedded when it is present in all aspects of customer value creation. By this time, data and analytics results become products. These products are owned and managed by business units and functions themselves. When analytics plane gets close to transactional plane in its real-time capability, interesting things start to happen. In other words, when data-driven insight becomes available with low latency, its applicability explodes across business domains. In this way, real-time capability directly contributes to analytics pervasiveness. Anything centralized tends to turn into bottleneck, be it about computing or organizational resources. Therefore, the ultimate solution for scalability builds on distribution. In case of data capabilities, that can only happen through orchestrated automation and self-service. We finally have a complete picture on data capability maturity levels. In the big picture, it's about increasing complexity and scale, calling for carefully designed operating model architecture and technology platform utilization, and combined with equally careful change management. As the final step in this introductory video, let's have a look to maturity model use cases. Data capability maturity model uses are many, but the most apparent use cases are these. In its simplest form, a maturity model supports navigation across data capabilities minefield. With clarity on the big picture, the risk of missing critical capabilities becomes significantly smaller. In the context of strategic planning, maturity model helps to identify key capabilities and their dependencies. For example, what is the data stack needed for high-performance data engineering? Or what are the key elements to scale up data analytics throughput? Communication is an essential part of data capability buildup, not only for the overall alignment, but also to bridge the gaps between data teams and business domains, or between data engineers and subject matter experts. All of the above combined, a data capability maturity model becomes an essential tool for strategic change management. Thank you for your time. Next video will discuss maturity model applied to a real case. Once available, a link to that video will be added in the description below. Be sure to check that one out. In the meantime, please like the video and let me know what you think. Going forward, what would you like to see in upcoming videos on maturity model? Send me an email or write your comments below. Thanks.